All right, problem 2-35. Solve each of the following equations without using the quadratic formula. So there's 4 different equations here we're looking to solve, and then we got to answer a question here on letter E. So letter A, y squared minus 6y equals 0. Well, first thing here is we know that this is going to be quadratic. We know this is quadratic. Why? Because we have a y squared term, so we have an input value here, or a variable that is raised to the second power. Now notice though, we also have a y here that's raised to the first power. So we have 2 different terms. We have 2 different y terms. When we have 2 different powers of y, a y squared and a y, we have to make sure the equation is set equal to 0. In this case, it's already set equal to 0. So, but when that happens, when you have 2 different terms, you know, one has squared and one that's not, you have to set equal to 0. So this one is already set equal to 0. So what we're going to do here is we're going to look and try to solve the quadratic using one of the methods that we know. Now they said that we cannot use the quadratic formula, so the first thing we want to do is, does it factor? And remember, the first step in factoring is to look for the greatest common factor, and in this case we have y times y minus 6 times y. So in either case here we can factor out a y. And when we factor out a y, we should have y minus 6 left over equals 0. So we factored out a GCF. And that was our y. So we factored it out there. Now we have y times the quantity of y minus 6 equals 0. 2 numbers that are being multiplied times each other to get 0 would allow us to use the zero product property. So we're going to set each factor equal to 0. So y should equal 0. And y minus 6 should equal 0. So remember, we're using the zero product property. And this one we already know is going to be 0. Y minus 6 equals 0. We add our 6 to each side, and we get y is equal to 6. So our 2 answers here, we get y equals 0 and y equals 6. So to check them, you could take them, plug them back in, or you can graph it and see where it crosses the x-axis. Either one of those would work. But I know here if I put 0 squared minus 6 times 0 should equal 0. Zero squared is 0. 6 times 0 is 0. So 0 minus 0 gives us 0, which is true. And then if we plug in 6 there, we've got 6 squared minus 6 times 6 should equal 0. 6 squared is 36. Minus 36 gives us 0 equals 0. All right, moving on to letter B here. Actually, let's make sure we mark our answers here so we can see them. So we have y equals 0 and y equals 6. Letter B, n squared plus 5n plus 7 equals 7. So once again, it is quadratic because we have a variable here that's being squared. And we also have 2 different powers here. We have n squared and we have n to the first power. So what we need to do is we need to make sure it's set equal to 0. So right now we have it equaling 7, so we need to subtract 7 from each side so that we can get this set equal to 0. So now we have n squared plus 5n. This would be positive 7 minus 7. It's going to give us a 0, and we're going to end up with 0 on this side too, which means we have this whole thing equals 0. So much like the problem we just did where we had y squared minus 6y, we have n squared plus a 5n. So now we're going to look to see, does it factor? And it does. We can factor out an n here. So when we do that, we say n times what gives us n squared? Well, that would have to be an n. And n times what gives us positive 5n? That would have to be plus 5. That all equals 0. Our next step is going to be using the zero product property, just like on the problem just before. We have two numbers whose product is 0, so let's set them both equal to 0. N is equal to 0, and that one's already solved. We have n plus 5 equals 0. So n equals 0 is n equals 0. For n plus 5, we subtract our 5 from each side. And we end up with n equals negative 5. So that means that our two solutions, we have 0 will work or negative 5 will work. And if we want to check them here, we want to use our original equation. We could plug them in. So we could say here that 0 squared plus 5 times 0 plus 7 should equal 7. 0 squared is 0, plus 5 times 0 is 0, plus 7. Obviously, that's going to be 7 equals 7. We know that is correct. And then let's try our negative 5. Let's put it in there. Remember to put parentheses around anything that you're plugging in, especially if it's negative. We have negative 5 squared plus 5 times negative 5 plus 7 should equal 7. Negative 5 squared is positive 25. 5 times negative 5 is going to be negative 25. So you could either say plus negative 25 or minus 25. It's the same thing. Plus 7 should equal 7. 25 minus 25 is 0. 0 plus 7 is 7. So that holds true. So our answer here, n equals 0 and n equals negative 5. All right, so moving on to the third and fourth problems here. For letter C, we have 2t squared minus 14t plus 3 equals 3. Now, if you've been following along what I've been doing on the first two, maybe you should pause it, try to work out this problem, and see if you can get it before watching me do it here. Here I go. I have t squared, and I have t. So I know it's quadratic, and I have two different t terms. I want to set it equal to 0, so I'm going to subtract 3 from each side. So I now have 2t squared minus 14t equals 0. Make sure you're careful here. You're trying to make this one 0, but it ends up making this one 0 too. Now we're going to look for the greatest common factor here. 2t squared and negative 14t. So they both have even coefficients, which means that 2 goes into both of them. And you can see obviously t is a factor in each of them. So our common factor that we're taking out is 2t. Now when we factor out 2t, 2t times what gives us 2t squared? That's obviously t. 2t times negative 7 gives us negative 14t. So we have minus 7 equals 0. Now we can use our zero product property again. Let's set each factor equal to 0. So 2t equals 0. And then t minus 7 equals 0. Well, for this one, it's just like saying here, 2 times what number is 0, or you can undo it by dividing by 2 on each side. Either way, you still end up with t equals 0. And then I'm going to add 7 to each side. and I get that t equals 7. So the two answers I'm looking at here are t equals 0 and t equals 7. For time's sake, since I'm already over 10 minutes here, I'm going to go ahead and let you know these are correct, but you can still plug them in to check them on your own. So our answer for C is t equals 0 or t equals 7. D, 1/3 x squared plus 3x minus 4 equals -4. Again, quadratic, two different x terms, got to get it equal to 0. How do you undo or how do you fill in a hole when you're missing 4? You have to do the inverse operation or add 4. I'm going to add 4 to this side, but when I do it to one side of the equation, you have to do it to the other side. And just like our 3 previous problems, this is going to be 0, and so is this. So let's just bring down what we already have. 1/3 x squared plus 3x equals 0. Now, when we're looking for our greatest common factor here, we're looking to see, well, what number goes into 1/3 and goes into 3? Well, our greatest common factor in this case is going to end up being 1/3. 1/3 is going to go into 1/3 one time, and 1/3 goes into 3 9 times. So our greatest common factor is 1/3, and then we have an x that can go into both of them as well. So we're going to have 1/3 x. So let's see what that looks like. If we do 1/3 x, and we say 1/3 x times what gives us 1/3 x squared. Obviously that's an x, just like on the previous types of problems we have had up here. And then 1/3 times what gives us 3x. And if you're a little stuck there, if you think about it, you could also look at as you're dividing each of these by 1/3 x, what you already have up here. 3 divided by 1/3 is going to be 9, or 1/3 times 9 gives us 3. So we're going to have a 9 here. If you're trying to make sense of that, just distribute this through and see if you get the same thing here. 1/3 times 1/3 x times x gives us 1/3 x squared, and 1/3 x times 9, 1/3 of 9 is 3, and then you have your x. So let's just take it, set each of them equal to 0. Now this one, to get, so we have just an x, I'm going to have to multiply each side by 3, but really that's not going to change anything for us. We're still going to get x equals 0. And then when we subtract 9 and subtract 9, we'll get that x could equal -9. Now you can take it, plug them back in to your original equation to make sure they work. I'm going to tell you right now, just for time's sake, I don't want this video to drag out any longer, but these two answers are correct. So you do need to make sure you get in the habit of checking your own work, but in this case, your answer is going to be 0 and -9. All right, we have the last little part here, looking at E. It says 0 is one of the solutions of each of the above equations. What do all of the above equations have in common that causes them to have 0 as a solution? As we look at that, you'll see that when we set each of them equal to 0, we only have 2 terms, and we can factor out the variable from each of those terms there. So if we're looking to say what do they have in common, we could say in each problem, we could say if we're looking at them like they're in standard form, we have just ax squared plus bx equals 0. So in every one of them, the c term canceled out when we moved it and set it equal to 0. So that allowed us to factor an x out each time. or whatever the variable was. So in that case, they remember our variable always was one part of the greatest common factor. So when we pulled that out there, we didn't have any addition or subtraction, so we had to set that equal to 0, which made it really easy. That's why we ended up with 0 each time. If you have questions, please make sure you ask your teacher. Otherwise, thanks for watching.